I combine 15b and 15c together, okay, 15b and 15c together. This is talking about the median mean for continuous random variable. Okay, I still have this 5 points here. Can you see that? I still have that 5 points. Okay, let's think about expected value. That's always the first thing we're interested in. Okay, that's the first thing we're interested in. So expected value before in discrete random variable. Okay, I just write a column here for discrete random variable. If you can remember, that's the sum for x times px. So for the value you can take, you times the probability. Okay, times the probability that that value can occur, and you sum all of that. Okay, you sum all of that. That is expected x. Capital X. Okay, capital X. And we have expected gx. Okay, so expected gx is not g expected x. So what is that is you go the sum as well. You have the gx function. You can, for example, x squared. So you calculate, for example, your x can take 1, 2, 3, 4, and then your x squared can take 1, 4, 9, 16. Okay, so that's your gx. That's the value for the gx. And you times the probability for that x to occur. Okay, and you sum all of that. That's what we talk for discrete random variable. And let's compare. Let's compare what? Let's compare the continuous one. So what is the expected x can be? Okay. Is the x times what? Times the density function. Okay, times the density function. But instead of the summation sign, what we have is an integral sign. Why we have integral signs? Because there's infinite many points. You can't add them. So summation is another way of writing summation. Writing the sum sign here. Okay. Integral is a sum as well. It's sum of all the area under the curve. It's sum all the y values. But this is for continuous. And that is for discrete. Okay, so they are the same thing. They are all the sum for some values. They are all the sum for some values. But sum for what? One is sum for continuous because it's countless number. Okay, you can't just really write 1.1, 1.11, 1.111, like it's infinite many numbers. So you use the summation sign instead, the integral sign instead. So summation and integral, they are the same thing. They all represent sum, okay, represent sum. Integral is sum for continuous random variable and summation sign is sum for discrete random variable. So can you see it exactly looks the same? Okay, it exactly looks the same. It's x times the density function, and the other one is x times the probability of x. Okay, so for discrete random variable, you have mass function, which represent by px. But for continuous random variable, what you have is not px. You have the fx, which is the density function. So you use the x to time with the fx. And be aware of the integral. Although I read negative infinity to positive infinity here, but this must be right with suitable domain. Okay, it must be suitable domain. As I talked about last lesson, the area under the curve is not negative infinity to positive infinity because for some x you have 0, okay, 0 area. So it's a suitable domain. For example, your x is in between 0 and 1. Then you put 0 to 1 here. If your x is 2 to 100, you put 2 to 100 here. So it's a suitable domain. The negative infinity to positive infinity is just a book notation. What you need to adjust is adjust that to a suitable domain. So what is the domain given to you? What is the valid number you use for that function? Okay, so your x can only take, for example, 0 to 100. So you put 0 to 100 on the domain. Okay, that's expected x. Very lucky we still have that formula stay here. That doesn't change. Okay, that doesn't change. That is still the same as the discrete probability function. If it's a linear transformation, you still have a times expected x plus b. Okay, a times expected x plus b. And the next one, what we talk about is the gx again. So again, it's not equals to that as well for continuous. But instead, what we will have is we use gx times the density function, and we integral that, which means we sum that from a suitable domain. Okay, it's exactly the same as what we have here. Okay, the gx times px, and we sum all of that. It's exactly the same as discrete. Instead, we write an integral sign instead of the summation sign here. Okay, so that's expected x. You can see we only change the summation symbol to an integral symbol, and nothing really changed. It still follows the same. That's why I said chapter 13 that page 8 is very, very important, because all the formula you use for 4 chapters. Okay, the formula used for 4 chapters. That's expected value. Okay, for median, what is median? Median is 50%. Okay, median is 50%. So what you will do is, you want to find the x smaller than value that just give you a half. For example, we have fx looks like that. Okay, we have fx looks like that. That's f of x, that's x. And we want to find which x can give me 0.5 and 0.5 here. Okay, which x can give, let's say that's an m. Okay, it's a median. We use the m to represent that. Which part can separate the area into 0.5 and 0.5? Because the whole area will be 1. Okay, whole area will be 1. Then we see where is the 0.5. So what we can do is use calculator to solve. Let's say in this question we have 0 to 5, for example, 0 to 5 as our domain. And we have 0 on that side and 0 on the other side. Then we find integral from 0 to m. We integral that function, and we make that equals to 0.5. We're trying to solve that on calculator. We're trying to solve that on calculator. Okay, solve that, comma, m, and what that value is. You find that value. Sometimes you can find more than one value of m on your calculator. You will choose the m in between 0 to 5. Okay, there will be only one m in between 0 to 5. Can give you that equation, make that equation true. But you can have negative values. You can have value after 5, but you only choose the one in between 0 to 5. Marking your stack. I see some of you still write CAS calculator instructions on the paper. Okay, it's not correct. Do not write calculator instruction on the calculator. So what is calculator instruction? For example, this question. Okay, that is calculator instruction. Okay, that is calculator instruction. Because the other calculator is not looks like that. Their sole function is not looks like that. This is calculator instruction. You are not going to write this on the paper. So on the paper, what you're going to write is this. Okay, next line is m equals to what? Directly give answers. Okay, you don't need the calculator instruction. You don't need to write that thing. So you have the equation here and bring that down and write the m values. Okay, there's no calculator instruction on the paper. Another thing, okay, this course is called math method. Okay, you need to show your method. It's not a math answer part, okay? So you write method, and the method gives an answer. If you can see the question is 2 marks, if you just give me an answer, definitely you lose 1, okay? Without any doubt. Like math method is your answer come from a method. Okay, remember the question when we talk about the last page when you talk about the volume and the cost on the paper. Okay, you show a method. How do you get that volume? You show another method. How do you get the cost? Like your answer needs to come from somewhere. Okay, you just take 5 seconds to write that equation down. Do not just feel confident enough and just give me an answer. Your answer can be wrong and you lose all the marks. Okay, not even method mark. Even though you give me a wrong answer, if you follow some correct procedure, if the method looks correct, I know what you're trying to do, you still get the method mark and you lose the answer mark. Can you see, like, if you just write the answer, you lose 2 directly. Okay, if you write something, show me something, you get 1 method mark. Okay, and that's only 5 seconds, you write that. Okay, so make sure all the answer comes from somewhere. Okay, show me what you have before you write the answer. Okay, even though it's a very long equation, doesn't matter. You don't need to simplify it. You can directly give answer on the next line, but you need to show the original equation to me. Okay, that's something I don't want to see you did this wrong again in Sec 3. Okay, it's very important because some of you lose a lot of method mark, okay, in the paper, and I don't want to see that. It's like really a pity. You lose the easy mark. Okay, you lose the easy mark. Okay, come back to this. So, for example, this question, if asked you for the median, so the first method mark is that. Okay, the second answer mark is m equals to what? Okay, that's two different marks. Okay, two different marks. If you directly write m equals to 0.3, and it's wrong. Okay, and it's wrong. That's how we find median. And number 3 is how do we find mode. Okay, mode is quite easy to see from here because the definition for mode is the most frequent number. Okay, most frequent occurred number. So in this one, you don't really know the probability on the single point. But what you can see is the whole density function. And you can see where is the highest point on the density function. So, okay, this is the highest point on the density. Then that is the mode. That x is the mode, not the y value, okay? It's the x. That x is the mode. On this graph, that is the highest point. Then that is called the mode. On this one, that is the highest y value. Then that is the mode. Okay, the mode is where is the maximum point, the x value of the maximum point on your density function. Okay, mode is the x value of the maximum point on the density function. Okay, so that's your mode. Variance. Okay, do you remember what's the variance for discrete? We have two equations for variance. VARX, okay, that's for discrete, equals to, let's see, expected bracket x minus mu squared. Okay, we want to find the expected value for all the x, the distance for all the x from the mu. Okay, the expected value of the distance from the all the x to the mu. Okay, that distance. Okay, the difference between the x and the mu, and we find the expected value of that. I've shown you how to do that, and I said I don't really like this method. This is not a preferred method. Instead, the preferred method will be the expected x squared minus expected x, and then we square the mu. That will be a preferred method. Okay, that will be a preferred method. Similarly, we will have similar equation here. Okay, so the variance for continuous, okay, is expected. Okay, it's still expected of that. So how do we find the expected of that? Let's go back to number 1. Expected gx equals to integral from negative infinity to positive infinity gx times the density function. So now we want to find the expected value for that gx. Your gx is x minus mu squared. Then you will have x minus mu squared times the density function and to a suitable domain. Okay, that's for this one. And we can also use this one, which is the expected x squared minus mu squared. So, okay, sorry, I forgot something here. That needs to have a bracket square as well. I missed the square there. Okay, everyone, the square over there in red. Because it's mu squared, what you find is only mu, and you need to square that as well. Missing a square there. So what is expected x squared? You will use the x squared times fx and integral from a suitable domain and minus the mu squared. Okay, and minus the mu squared. It's pretty much the same as the previous session as well. And what's standard deviation? Okay, standard deviation is just square root of variance. That never change. Okay, it doesn't matter what kind of random variable, that is always true. Variance is always the square of standard deviation. Okay, it's always the square of the standard deviation. Okay, and we have quartiles and percentiles. Okay, quartiles and percentiles. They are the same thing. Okay, they are the same thing. Okay, oh, it's 4. Okay. Okay, quartiles and percentiles. So quartiles and percentile both define the value of a random variable x, below which is given a proportion of the distribution fields. Okay, I will explain that in normal English. Okay, just read it. The only difference, I want to see the only difference. The only difference is that a quartile is a probability value expressed as decimal, and percentile is expressed as a percentage. Okay, if you talk about quartile, it's 0.6. If you talk about percentile, it's the 60th percentile. Okay, it's the 60%. It's the 60th percentile. So percentile is in percentage, and quartile is in decimals. Okay, that's the difference. That's the only difference. And then they are the same definition. So what is the definition? Let's have a think. If probability x less than k give you 0.6, then k is the 0.6 quartile, or it's also called the 60th percentile. So basically you have a distribution. Okay, you have a distribution. And you want to see, okay, this number, well, let's say that it's from -1 to 10, and you have 5 here. Okay, what you want to know is 5 is what percentile or what quartile. So you will find the area to the left of that point. To the left of that point. Not to the right, it's to the left of that point. If that's 0.8. What you will say is 5 is the 0.8 quartile, or 5 is the 80th percentile. Okay, you have a number first. You find the area to the left. Whatever is that area, you will say that's 0.8 quartile or 80th percentile. Because 0.8 is 80%, then it's the 80th percentile. Okay, so quartile and percentile, they're the same definition. You have a number, you find the area to the left of that number, and then the area under the curve will become either the quartile or the percentile. Okay, so that's the definition. So what we have on page 5 is pure definition. Expected values, standard deviation, variance, mean, mode. Yep. Formulas? Yeah. Well, you better remember of that. Like on the formula sheet, you have some of that, but the equation is easy to understand, like to remember, like you just purely remember. You need to know how to apply to it. So sometimes you can't always go back to the formula sheet and find whatever I need. Like it's more, you need to remember the formula, then we can move on to the next step. So better remember that, encourage you to remember, but there's formula sheet to support you as well, but do not really think about using that. Okay, if you really want to have a good mark in your final VC, you're not using any reference book or the materials in the exam. You basically know everything by heart. Okay, you basically know everything by heart. You're not using them. You don't have time to use them. But you can use them, that's here to support you. Okay, you take it in, if you forget anything, you go back to look at it. Okay, not stopping you for bounding your reference book, you still use it, you still have it, you put there, if you forget something, okay, hopefully you're not. Okay, hopefully you're not. Okay, let's have a look at example 5. How many examples we have? 5, 6, 7, 8, 9. Okay, we have a lot of examples here. Let's do an easy one first. Okay, for the continuous random variable with probability density function that, and 0 anywhere else. Okay, that's a hybrid function. Can you see? Like they're not really right in the hybrid function form, but it represents a hybrid function. So we have that one. Can you just use a small space first to sketch this graph for me? Okay, to sketch this density function for me. Okay, it's a quadratic. You can sketch that one. You label the turning point, x-intercept, and any important points you need. How many of you forget the y equals to 0? Okay, no? Okay, good. You need to sketch the y equals to 0. Okay, the two red lines there, you must sketch them. Do you remember we actually did this question before in example 1 or 2? We have shown that the area under the curve is 1 already. Okay, we use the same function here. We use the same function here. Let's find the mean. Okay, let's find the mean for this question. Okay, anyone remember what's the mean formula? Mean is expected x. Okay, what is that? Go back to the previous page. Integral. What value I need? 2 and 0. You're not going to write negative infinity to positive infinity, okay? And what we have here? X and fx. Okay, fx is 3 on 4x. 2 minus x, that's fx. And dx. Okay, that's the equation. Okay, that's the equation. And we just evaluate that. Okay, stop using your calculator, use hand. Okay, that's part 1 exam. Okay, that's part 1 exam. There's no CAS available on that. It's a very easy polynomial equation. Okay, it's so easy to integral. So we have 3 on 2 x squared minus 3 on 4 x cubed dx. And we have 1 on 2 x cubed minus, okay, divide by 4, 3 on 16 x to the power 4, 0 to 2. And if I put 2 in, that's 1 on 2 times 8 minus 3 on 16 times 16 minus 0 on 0. 4 minus 3, I have 1. My expected value is 1. Okay, my expected value is 1. Okay, what is the median? Without looking back the formula, what is the median? You can tell the answer directly from this. 1 is a symmetrical graph. Okay, it's 1 and the area. Okay, if you sketch from the turning point, half half, so median is 1. C, what is the mode? 1. Okay, highest point is 1, 3 on 4. Then that's 1. Okay, median, mode, mean, they're all the same point. Okay, median, mode, and mean, they're the same point. That's because this graph is too symmetrical. Okay, it's too perfect, the shape. So that's why it all exists on the same point. Okay. Next one is the variance. Next one is the variance. Which formula you would like to use? First one or second one? Second one. Okay, second one looks better, but you need to know the first one. Okay, you need to know the first one. You need to at least try once how to use that formula to calculate variance. Okay, how to use that formula to calculate variance. Well, I think I have enough time. I'll just show you once, okay, how to do with that equation. So, and I will show you the easy way as well. We're looking for the variance of x. And that is equivalent to expected x minus mu squared. Okay, expected gx. So we will have x minus 1 squared. That's my gx. Mu is 1 in this case. Times fx. Fx is 3 on 4 x times x minus 1 squared. Not squared, x. And finish the bracket, dx. We have 0 to 2. Okay, gx, that's the gx, that's the fx. Okay, gx times fx, and then we want to find the integral between the proper domain, which is 0 to 2. What you need to do if you do it by hand, expand everything, integral, substitute. Okay, but well, I don't really have the patience to do that. Well, I will start from another line. You can evaluate from that. Okay, expand, combine, derive, anti-derive, and substitute 2 and 0. Yep. Okay, it's not x minus 1. That's correct. Okay, thank you. Okay, variance of x. It is also equals to that. Okay, it is also equals to that. What I will have is integral from 0 to 2, x squared, times 3 over 4x, and 2 minus x, dx, and minus 1 squared. Okay, the gx in this case will be x squared. Okay, the gx will be x squared. So what I will have is 3 on 2 x to the power of 3 minus 3 on 4 to the power of x to the power of 4. 0 to 2 minus 1. Well, you put 4 in, 60, not 2 in, that's 8. Wait, I haven't, no, I haven't integral yet. That's only expansion. That's only expand. And I need to integral that. 3 on 8 x to the power of 4 minus 3 on 15 x to the power of 5. And then 0 to 2 and minus the 1. Okay, we have dx here. Do not forget your dx. Okay, that equals to 3 on 8 times 16 minus 3 on 15 times 32 and minus 1. Yep. Yes, you are correct. Yes. Okay, see, that's the problem, not calculate a lot. Become a teacher and you're not practicing anymore. If you stop practicing, you'll be the same as me, okay? That's 2, that's 5, that's 8. That's 6 minus 24 on 5. Minus 5 on 5. That can become 30 on 5. One on 5. Okay, 1 on 5 is the variance. Okay, that's variance, and we have E is the standard deviation. Okay, standard deviation use the sign sigma. It's called SDX. That's square root of 1 on 5, and that equals to root 5 on 5. Okay, that's root 5 on 5. Okay, last one, F. Okay, in F, what we're looking for is the 80th percentile. Okay, remember, 80th percentile is a number. You want to find the number. On the left of that number, the area under the curve will be 0.8. So basically, you're trying to solve for a number. Okay, you're trying to solve for a number. So you're not talking about the mean, not talking about the standard deviation. You're just purely talking about the area under the curve. Okay, you're not going to times that with x. You're not going to times with x squared. So what we're going to do is the lowest value is 0. Let's say from 0 to k. I need to start from the left because it's the area on the left of that point. Okay, so what we have is 3 on 4x and 2 minus x dx. And I want that value to be 0.8. That's 80th percentile, okay, which is 0.8. Okay, which is 0.8. Okay, so we want to find the integral for that. No equal sign on that side, it's 0.8 here. We have 3 on 4x squared, 1 on 4x cubed, and we have 0 to k equals to 0.8. Let's have 4 on 5 here. Well, okay, first, you can directly solve from this step. Okay, I don't think I can solve this by hand, really. So you can solve this directly by calculator. But like, I'm just go through, if it's asking you to do it by hand, what you need to do. Okay, so after that, we have 3 on 4k squared minus 1 on 4k cubed equals to 4 on 5. Because when you sub 0, you will still have 0. And you just solve for that. Menu 3, 1, 3 on 4, like 0.75 times x squared minus 0.25 times x cubed equals to 0.8, comma x. Okay, we have this equation here. Double check it, which is correct. Equal. Okay, we have so many values here. Negative 1.4, 2 point something. I can only take that one. Okay, let's go for 2 decimal places. So it's 1.43 here. Okay, 1.43 here. .43 is approximately the 80th percentile. Okay, so approximately 80th percentile. Okay, that is the K value. Okay, so I just go through all the formulas on the first page. Okay, on this page, I have go through everything what you need to do. So You still have 5 minutes, and I want to do some homework before tomorrow's lesson. I want to do example 6 and example 7. Example 8 will be different. Okay, example 8 will be another thing. I will talk about example 8 later. But I want you to do example 6 and example 7 before tomorrow's lesson. Okay?